All right, now we're going to talk about what bile is and how it's transferred throughout the digestive system. All right, so what is bile? Bile is a chemical that is used for the emulsification of fat. So what does emulsification of fats mean? Like before, we talked about physically breaking down fat. So if you have a piece of triglyceride, for example, so if we were talking about bile here, and we have this piece of fat, triglyceride here. When bile comes in and binds to triglyceride, it breaks it down into smaller pieces of triglyceride, but the chemical structure is still intact, right? And so what was that enzyme that breaks down triglycerides chemically? Those were those lipases. So lipases break down everything, all right? So we have bile. Now we want to know where bile is made, where is it stored, how is it stimulated, all right? So first of all, where is the bile made? So this is a nice little schematic I'm trying to show you here of just the ducts, all right? So the bile is carried through these ducts. And so what's unique about ducts in the digestive system is that they're bidirectional. Unlike blood vessels, when they're unidirectional, they can go one way. They're bidirectional, as in they can go back and forth, okay, based on the different gradients of pressure. All right. So I didn't draw the liver or the pancreas. I did draw the gallbladder. So you have the gallbladder here. All right, so where is bile made? Well, bile is made in the liver. All right, whenever it's made in the liver, it comes down these two ducts. You have the right and left hepatic ducts. All right, so I'll draw little arrows here in pink. So the pink is bile. Comes in, and the first thing that happens is it gets stored in the gallbladder. So the way it gets stored, it goes through the hepatic duct, and then finally it migrates or mobilizes through the cystic duct, so the duct that connects the gallbladder, all right? And then finally, as it goes up, it relocates in the gallbladder. So you see this migration that's taking place here. Now let's use a different color just to show direction. All right. Now, whenever there's a certain hormone that stimulates the contraction of gallbladder, what was that hormone? Does anybody remember? It was called CCK. So CCK, cholecyclokinase, comes into the bloodstream and stimulates the contraction of the gallbladder to contract and launch any kind of bile that has in its reserve down this system. So what happens here now? Now when we look at the direction here, I'll have it in blue. Again, remember, bidirectional. So you see how we can have it coming this way, the opposite direction as we predicted before, right? So it goes down the cystic duct here. And now what's really important here is you have the hepatic duct and you have the cystic duct. When those two join and release the gallbladder, because sometimes the liver creates its own bile and it secretes it outwards rather than storing it in gallbladder. Now, here, it combines to create this new structure called the common bile duct. So the common bile duct is the joining of the cystic and the hepatic ducts. All right, and then now, so the gallbladder contracts, bile comes down, 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 and then finally here, it goes down and we have this final region here where the common bile duct combines with the pancreatic duct. So where do you think the pancreatic duct releases? So you remember, pancreatic duct secretes bicarbonate, so HCO3 minus. What is that? That's a base. And also zymogen, so inactive enzymes. So what also secretes, so whenever CCK stimulates the contraction of the gallbladder, it also secretes zymogens from the pancreatic duct, all right, from the acinar cells in the pancreas, which again is transferred through the pancreatic duct, okay? What stimulates the secretion of bicarbonate? What was that hormone? Secretin. So if you remember secretin, we'll put this in here in parentheses. Secretin, again, secreted from these enteroendocrine cells of the duodenum. So both CCK and secretin are secreted for enteroendocrine cells from the duodenum in order to allow for this bile and pancreatic juices to be released. Now all of this now, you have these new juices that come in, the pancreatic juices come in, and then you have this entire structure. So I didn't really draw this structure here, but the common bile duct and the pancreatic duct unload all their chemical composition into where? Into the small intestine, and specifically in the duodenum, where in the duodenum you begin further digestion, majority of absorption that takes place, and further processing of the materials.